What's up, everybody? Welcome back. Today, we are working on configuring a 48 megahertz clock on our Raspberry Pi Pico, with the intent of using it to power USB so that we can write some controller firmware that pretends to be an Xbox controller. So we are making an Xbox controller. It's got to talk, right? We need to turn on USB. We have been kind of like sidestepping the whole Raspberry Pi Pico SDK because, you know, we hate ourselves, but also because it's kind of fun, right? We want to do, we've been trying to see, can we write the whole controller firmware ourselves in Zig? And so we've got kind of like a system set up that's kind of working to some extent. You know, this guy, typically it's just like we have a memory bus. That memory bus has a bunch of like little hardware controllers on him, and we can write to those controllers using 32-bit writes. And so we've got like kind of a system where we can define where those registers live in memory. Those generate like some types for us that have all of the nice little names of stuff, right? So if we want to like talk UART, maybe we have like a UART control register that has like, you know, a way for us to set like the RTS thing, the DTR pin bit, the RXE bit, TXE bit, like all these guys come straight from the datasheet. We generate a type that represents that guy, and we map him to a memory location, right? So we've got kind of all that set up. And so the PLL is just another guy on this chip. What the fuck is a PLL, you might ask? I was also asking that not that long ago, maybe like 30 minutes ago. So my understanding at this point, which, you know, is probably highly flawed, but good enough, is we need time, right? Time needs to come from somewhere. And where it comes from on this guy is, you know, you have like some like quartz rock, and you just like cut him up. You take a knife, you cut off a little slice of quartz. You zap this guy with some electricity, zip, 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 and he gets a little, you know, he gets a little cold and starts shivering because you're like, maybe he's shocked. I don't know. He starts wiggling because you're zapping him with electricity. He outputs like some really stable clock. Boom, right? This thing on our chip, 12 megahertz. And, you know, I guess the factory has some sort of way to make a really, really precise cut of this rock that will always output 12 megahertz. Boom. Now, 12 megahertz, you might notice, is less than 48 megahertz. Uh-oh, what the fuck do we do now? Right? Because we need a 48 megahertz clock for USB. Well, it turns out that there are these things called phase-locked loops. And, you know, from reading the Wikipedia page 30 minutes ago, we understand it a little bit. Basically, the way this thing works is he's got like a guy that can wiggle a lot faster than 12 megahertz, right? Like maybe like 1.6 gigahertz. And the speed is controlled by how much voltage you pump into him, right? So you kind of have like, you know, voltage input to frequency output, and it's kind of like, boom, something like this, right? This guy is going to run really fucking fast, but not that precisely. So what you do is you take this like fast fucking signal, right? You say, sample this like 1 every like 50 times, right? 1 in 50 times, and then try to line up this like 1 in 50 of this guy, this like 50 times divide of this with this 12 megahertz clock, right? And so what this can do is there's like a little bit of a feedback mechanism where you have like the, you know, the oscillator, you've got like, you know, some sort of like input, right? And you measure this guy with like a divide. So you could say like divide by 50 over here. And then you kind of like tweak this voltage so that the output you get is like what you wanted, essentially. And that's all done like in electronics in some way that I don't really understand, right? But it's, you know, basically you take really fucking fast thing and then try to make it so that some divider of that thing is the frequency that you feed, the other frequency that you feed in. I love talking about magic rocks. Yeah, I'm sure that like this is how I think of it. But where are the rock girls? Do they wiggle too? Yeah, that's actually what they did, is they took a bunch of dancing rock girls and they put them all inside the chip. And they're very precise, you know? I don't like the idea that we were talking about cutting them up though, So maybe we stop this analogy now. But anyways, so what we have to do is we basically have to configure like this input fixed 12 megahertz. We got the rock. Right now, theoretically, for a different board setup, you might have a different rock in there. So this is like a parameter to this thing, but in our case, it's fixed at 12 megahertz. So we have to configure essentially this guy. They also have, once you've configured this might still be like too fast, right? If we were to like, this might be still running at like 250 megahertz at this point or something, right? Just because like it might be the way that the divider here worked out. You also sometimes want to run this guy. The faster you run this guy, the less jitter you'll have on your output clocks. And so there's like a couple more dividers out here that you can do to like convert this guy into 48 megahertz after, right? So we configure these. We configure this parameter, this parameter, this parameter. This is fixed, but we might have to tell what it is. I think not. I think that that's kind of implicit. Yeah. And so we do that by writing to memory map registers, and I guess we will figure out where those live and what they look like. So somewhere in this data sheet for the RP2040, the system on a chip that lives on the Raspberry Pi Pico, he is going to have PLL sys and PLL USB registers. I guess we are PLL USB, so we're looking at this guy. So I guess we're going to say maybe somewhere, I guess this means that we have two registers that have the same shape, right? So maybe having a function here that returns like a PLL, like a two sets of registers, right? Yes, two sets of registers. So we're going to have like a PLL type, or a PLL function, sorry, that returns a type based off of, where he lives. So we're going to be like, here is your base address, and in here, you're going to return some structure. And one of the elements in your structure is going to be, whichever thing we care about, right? So control status. And this is going to come from a register definition, registers dot probably PLLCS with offset 0. Okay, so we need to define this guy. So what we have done is we've kind of made like a code generator that takes in a blob of JSON and generates a bunch of types of him, right? So here we're going to be like, we have our PLLCS type. He has these fields. I don't know what those fields are yet, but if we just look here, we have, ref div at bits 0 to 5. So we just write that down, 0 to 5. We have bypass at 8. And we have lock at 31. Now we have the ability to give these guys like special types, but it looks like these are just like numbers. So I think we're fine, right? Seems fine. So if we compile now, hopefully, we go into, our registers file, and if we look for PLLCS, this guy now has a bunch of functions that lets us like manipulate these registers, right? So we have in here, we have like write the lock value, write the bypass value, write the ref div value. We don't have like read only parameters right now, but it's fine. We know that lock is read only, and we'll just like look at it on read. Okay. So now we should be able to be like, now we should probably put this not bisecting the UART shit. Okay. We have PLL USB is a PLL whose base address is this guy. Boom. Simple. And if we want to talk to this guy, we should just be able to like set these parameters. I guess we're missing like, do we need to turn this thing on? Right? I don't know. This is we forgot to write down times. It's been a while since I've been doing the YouTube timestamps. I forgot. So yeah, do the PLLs, are they like a chip that needs to be powered on? Resets base. Yeah, here we go. So what are our things in here? Do any of these things say PLL? Yes. PLL USB is a guy that we have to turn on. So that means that, like, if we look at the register definitions and we look at the reset fields, we have reset control has PLL USB at 13. So we'll kind of do this. Slap that in there. Hype. Hype, hype, hype. So now we should be able to be like init USB PLL. Right? Simple. And he's going to take out PLL USB from reset. Then presumably he's gonna start talking to him, I guess. Right? So we're gonna be like PLL USB CS. And is there like some parameter that we can read from the PLL to check that he's on? That'd be kind of hype. You know, just so we can have like some sort of like incremental progress. So these guys are all read-write parameters. This is a read-write parameter. These are all read-write parameters. So everything's just kind of like a read-write. There's no kind of like constant read parameters that we can use to like check that this thing's on. But we can just try like writing to something and reading it back and see what happens, right? So we know that on reset, I guess, we should be reading that refdiv is 1 from CS. So if we read, just like read this value raw and breakpoint on this guy, we should see that this guy's value is 1. And if this is 1, then that's a good sign that we turn it off. So first let's do no reset. It should not be 1, right? That's our good clue there. He's mad because I forgot where the stars go in this language. It's at the end, not the beginning. And can we run this guy and just kind of see what happens? So can we info locals? So csreg is 1 there. Interesting. What if we put this thing into reset? Intentionally. Okay. So that's a little interesting. Because as far as I can tell, that means that this guy is on. But like, it shouldn't be on? Maybe info locals. Oh wait, hold on. Did I build? Maybe oh yeah, I did. Source file is more recent than executable. Why does it say that? It's confusing. Can we do let's just, how do I make sure that this thing is like working correctly? Take out the breakpoint and see if that doesn't trigger. Yeah, okay. So this is working. Now, I would have thought that this would put him into reset. The default's 1, so that's probably the value when reset is active. Oh, good point. Good point. Yeah, so if we try to write into this guy, we can do like write the value of 5 into PLL USB and then read him back. Nope, that's, sorry, not, what the fuck am I talking about? We're trying to write the value to refdiv? What is that register called? Yeah, refdiv. What do we call it in registers? Yeah, refdiv. So why is this not working? Oh, modify, my bad. My bad, okay. So now, info locals, he's 1. But if we take the chip out of reset and we set that guy, do we see 5? Nice. Nice, good eye. Good eye. Okay, so we have taken this thing out of reset and he is responding to our writes, which is sick. He is remembering what we wrote down. Which means that we should be able to just set the parameters to what we need them to be. So if we want a 48 megahertz clock, I think somewhere in here, they just told us what parameters the SDK uses to get that. So they said here, if you have a 12 megahertz clock, multiply that by 100 to get 1200 megahertz. So we're trying to run the voltage oscillator at 1200 megahertz. Divide that by 25 to get 48. Seems reasonable to me. So can we find those guys? Maybe. Where was this? In the PLL registers. So we are trying to set. I already forgot. Can we copy paste so that I don't forget? Zinka, thanks for the raid. What's up, guys? We are working on turning on the PLL on our Raspberry Pi Pico using Zig no SDK. Where PLL is a clock divisor, we're trying to get, or clock speed upper, I guess. We've got like a 12 megahertz rock. We want a 48 megahertz signal. So yeah, hope you had a good stream. Thanks for the raid, and I'm just gonna keep going. Okay, so we need FBdiv at 100. So that's this guy. So he is offset 8. We need this guy's parameters. So we need to make a definition of PLL FBdiv. And he's just got a single field. Which is, we'll just call divider, I guess. Div. And this takes up bits 0 to 11. Others are reserved. This guy lives over here in the PLL at FBdiv, registers PLL FBdiv, init with base plus whatever the offset was, which was 8 hex, which is the same as 8 in decimal. So we should be able to be like PLL USB FBdiv modify with a divider value of 100. All right. I think that all kind of works out. Does that file? Sure does. Hype. So that's parameter 1 out of the way. Then we need our output dividers to get that 12,000 megahertz into 48. So where that's this register, I guess. Divide by 1 to 7, divide by 1 to 7. Pipe. How is the debug tool connected? Maybe it could conflict with your pin configuration. What do you mean? Like, are you talking about the oscilloscope that I'm going to hook up? I think that I'm just going to slap it onto the pins that matter, I think. Or you're asking about like the debug pins for the debugger. I don't think it conflicts at all. I don't see how it would. I think it's fine. Okay. So we need to divide the output that will be running at 1200 megahertz down to 48. So slap a couple dividers on here. So that means that we need this register, prim. PLL prim. So PLL prim, this guy has fields of div 1, which is at 16 to 18, and div 2, which is at 12 to 14. Okay. And this guy is at offset of C. So here we're just like prim registers PLL prim init with the base plus this offset. All right. This is going pretty smoothly, actually, to be honest. So we don't touch the reserved fields, and we modify a combination of these guys. I think we can define this combination at comp time, and we give him a bunch of options that we're kind of like slipping together, I believe is the way that we design this API. So we say like, use the function on this guy that is div 1 and div 2, just slap 2 5s in there. That compiles, which is kind of surprising and nice. Which means that we should be good to go. I wonder if we're supposed to be writing comp time in all these places, or if the compiler will figure it out for us. Because this is technically a function call. But whatever, it's fine. The combination ones are the ones that are really important to get right. Okay. So I guess we just check that these guys are what we expect. So we read, fbdiv, and we read prim, and just try to prove to ourselves that those are in fact correct. So prim, maybe print as boolean. So this is 10101, a bunch of zeros. So interestingly, that means that these this doesn't look right to me at all. Oh wait, hold on. We need to these 101s, these might not be at max bit. So we're looking at this might be 18 and 16. So 101 is 5. So this is probably bits 16, 17, 18. And then this is probably 5 here at bits 16, 15, 14, 13, 12. Okay, that lines up. And then so that means that these should be 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, okay, that looks right. Looks right. You probably want to wait till the lock bit is high. Yeah, true. True. Probably want to do that. Let's just double check fbdiv as well. So this is supposed to be just the value in the bottom bit. So we can just probably print this. 100. Yeah, okay. Cool. Cool. Yeah, you are right. We should wait till this thing is locked. Power-wise, do we need to change anything here? So set power when output is not required. Sure. So he'll automatically power down when you can. Post divider power down to save power set high when PL output not required. DSM power, nothing is achieved by setting this low. Okay, so interesting. And then to save power, set this high. So just all of these are just to turn shit off when they're not needed, and they all turn off when they're not needed by default. Can I see your dot files? No, they're not published anywhere. Hard life, I know. Okay, so now we just wait for lock. So while true, we do PLL USB CS read, and we look at the lock value. If this is equal to 1, break. Yeah. So we should see him get unstuck. And it looks like he's not, right? If we set a breakpoint here, we should hit it at some point. But we never do. So why the fuck not? What color scheme is that of my S? It's Sonic-Eye with term GUI colors off, using the default Alacrity color scheme. It's a lot of why while true? Because I didn't trust myself to get this right. Yeah, but you could do it like this, right? Which does the same thing. I don't know. It just kind of sometimes feels necessary to me that way. So the question is why is it not locking? We probably have to initialize this in some way. But I actually don't know. Is there some sort of start you have to write? Here is their. So before starting, oh, then they turn on. Which, oh, they clear? Whoa. So they set these guys to 0 in order to turn him on. But like, oh, am I like fucking stupid? Yeah, okay. So this is everything is off by default. And they're saying like you can turn it off when it's not needed. But we have to like there it's not like automatic. like I read it last time. So we need to turn on this and this, right? We need to turn on the dividers. We need to turn on the voltage controlled oscillator. And presumably we need to turn this on as well. Why, in their example, do they only turn on 2 things? Like, surely you want to turn on. Oh. Interesting. So they don't turn on the post divider until it's locked. Why? I guess because, like, as soon as this is on, it will get routed out to other stuff. But, like, the other stuff isn't connected yet. So I think I'm going to say, fuck you. I can do what I want. I'm going to do it all at once. And then later, it'll bite me in the ass and I'll get mad. Right? As is the classic around here. Oh, sorry, I didn't mean to backseat that hard. It's my first message of the day. Oh, no worries. No worries at all. I think it's one of those things where, you know, I don't care about like things like while true versus while this. I don't give a fuck at all. Right? But I know that some people like care about that a lot. It's funny reading Reddit comments on like this type of shit where you'll see people being like, that guy's so shit at programming, he put a switch statement in if case. And you're like, who cares, dude? Who fucking cares? Like, as long as you can understand what's going on, it's fine. And sometimes it makes sense to group stuff that way. But in reality, it doesn't matter. Classic. Yeah, I think I know better, but I know the chance of it biting me in the ass is very high. Well, I mean, that's just how I learn, right? When it bites me in the ass, that's how I'll know why they did it that way. Otherwise, I'll have no idea ever, right? So I intentionally take this route often. I think those kind of complaints are just super easy. Yeah, it's just like makes it easy to feel superior or whatever. Yeah, I agree. Also, hello, Clunky Boy. What up? What up? When it really matters, your yeah, I agree. I agree. It's real. I think that there's a lot of people, just generally. I think Redditors especially, like there's something that makes you feel good when you think that you saw something that other people don't see, right? There's this like superiority complex that you get where you go, by saying that something else is bad, I'm like implying that I'm not bad. And that makes me feel good. And it's like I think important to try to fight that very natural inclination. Right? I think that like everybody's guilty of it. But it's good to be aware of. YouTube videos about stuff like Undertale's code is so bad or disastrous for people's mental. Yeah. I agree. I don't care how much 100 I don't really care how much how the 100 lines are written or which keyword they use. I worry more about those 100 how those 100 line block fits with the system. Yeah. Yeah, agreed. Like there's definitely something to be said that like some things are objectively harder to understand and those are good to avoid. But it takes time to like understand what those are. And, you know, the things people nitpick on a lot of times are not those things, in my opinion. Okay, what are we doing? We're trying to power this bad boy on. So that means that we need this power register defined. So that's this guy, PLL power. Registers PLL power, and his fields were VCO PD at 5. We have post div PD at 3. We have DSM PD, which is useless, so we don't need to define it, and just general power down at 0. Yeah. Which means that we can define that guy over here. base plus whatever the fuck, OX04, which means that this guy should be here. It should be in order. It also makes sense to teach your brain that both things are the same, so you understand both immediately, no matter how people prefer it. Yeah, I'm a big fan of that. I'm a big fan of be able to read as much fucking code as possible. Like, and some code will look like shit to you, and so you need to get comfortable with that. Which is why, like, any like style code review comments, like, I just do not care at all. Like, it's like fine. Like, I get, like, if we have like a consistent style that we want to conform to, but that's why I'm a fan of just like fuck it, let the auto formatter run wild, and then don't fucking think about it, because it shouldn't matter. It shouldn't matter. All right. So here we need to take the power pin and then modify it so that we turn off a bunch of things at once. So we're gonna set, what was it? It's VCO, turn on the oscillator. We want to turn on the postive, and we want to turn on PD. And I guess here we will write a comment. It's like turn on everything. PD's power down. It's hard to like make a it's hard to choose here, where like it would be nice to like name these things in ways that are a little like nicer and make more sense, but also it's nice to name them in a way where you can tie them immediately back to the datasheet. So here I think it makes sense to like name the registers as close to the datasheet as possible, and then kind of turn those into higher level concepts up above, which makes us end up doing stuff like this, which is kind of, you know, writing comments like this. Yeah, okay. Are you sure it's not connected to anything? No, but whatever. So we hit the breakpoint, which means it locked. Hype. Hype, hype, hype. So that's good. So, and then if we set these things to 1, we don't lock anymore, I assume. Yeah, nice. Nice. All right. Everything on, baby. So at this point, the PLL should be on and running. And the rest of this stream is about trying to prove that fact to ourselves, right? So we could continue on, right? And just try to huck this clock into the USB system and try to use that directly. But it'll be hard for us to know. Like, it's just like another variable that could be wrong, right? And so it would be nice to be able to prove this thing independently. And we did find a way in Happy Hour, I think, to prove this to ourselves. And that is to route it to a GPIO, right? So if we look at the clocks segment of this data sheet, he's got a picture, right? We just look at this picture, we go, all of these clock sources get fed into all of these like named clocks, right? We have clock ref, clock sys, clock parry, clock RTC, clock USB, clock ADC, clock GPIO, right? And the thing that would have been nice is if we could feed this clock, the USB PLL, directly into like a timer, where like the timer would interrupt us every time it counts down all the way. We could just check, you know, within a second how many times this thing clicked. But this watchdog and timers thing was only fed through the watchdog, which intentionally divides this down to 1 microsecond, so it's hard for us to prove it that way. You are right that there is just an on-chip frequency counter, huh? So what I was going to say is we can route to a GPIO output and then use the oscilloscope to check that that is correct. But if this frequency counter works, that's kind of nicer. I'd be kind of curious how this thing works. So the on-chip frequency counter facilitates debugging of clock setup and also allows measurement of the frequencies of external clocks. That's kind of hype. That's kind of hype. I did just completely miss that. How the fuck does this thing work? Frequency counter measures the frequency of internal and external clocks by counting clock edges seen over a test interval. The interval is defined by counting cycles of clock ref, which must be driven from the oscillator or from stable external source of known frequency. So this thing can user can pick accuracy and test time using these guys. Okay, interesting. So longer time means more accurate, I guess. How the fuck does this thing work? So this thing connected to clock ref. But he's saying that you can use external clocks as well. So, like, if this thing is hooked up, he said he wants to be hooked up to the X oscillator. So if we hook the X oscillator up to this guy, he's running at 12 megahertz. So how can he measure something faster? Who knows? Who knows? But I guess maybe, you know, maybe it works. So where are like the using the frequency counters? Set the reference frequency, set the mux position of the source that they want to measure, wait for done status, read the result. Sure, Millennial, thanks for the prime. Much appreciated. SDK defines this guy, but I don't really care about this. Oh, but we can kind of look at him for inspiration. For inspo, okay, so we've got, the register. He waits for him to finish. He sets the reference frequency. Oh, I see. So he says, hey, we have our reference clock running at some guy. Then reads at some interval, no min or max, sets the source, and then just waits for the result. Okay. Sure. I mean, that's not crazy. Let's do that. Read it back. Check that it is correct, we'll say. Is there somebody that inspires or inspired you at some point? I think that word can probably mean a lot of different things to different people. I will say that I don't like the idea of, like, I know this isn't quite what you said, but like the idea of like heroes, right? The idea of like a person that you like look up to and want to be like, or like, I don't really like that idea because I think that you're putting too much pressure on like a thing that can never live up to your expectations, right? But you can see attributes of people that you like and would like to mimic. I think that's just like how humans work in general, right? Like we're kind of like, you go to school when you're a child and you try to fit in with the other kids, and if you don't, you get bullied, right? And so you like learn to just like be like the people around you. And we're like, I've been watching, I was watching Sons of Anarchy the other day. And dude, there's just been like this dumbass thing that happens in my brain since I was like a child where after I watch a thing on TV, I want, like, my brain is like subconsciously trying to imitate it in some way, right? So I just like felt different after watching Tarzan when I was a kid, right? Because I'm like, that guy runs on all fours and he jumps through the trees. I want to feel like I run on all fours and jump through the trees. And I know you're like a child, and it's like whatever, right? But like that instinct is still like in my body a little bit, right? And so I like watch Sons of Anarchy, and the guy in Sons of Anarchy, he walks so fucking stupid, man. He walks like his shoulders dip so much with every step, and his like pants are falling down, and it's so fucking stupid. He's got like so much like swagger, but I have to like fight this instinct to like walk a little bit more fucking stupid after I watch that show, just because it's like it's just like the way the brain imitate thing it like, right? Or even thing it don't like. And so I think that it makes sense to be conscious about when you interact with people. Like if people are doing something and you're like, damn, I want to be more like that. Like I think it makes sense to like mimic attributes, right? That makes a ton of sense. But to say like this one person inspired me, it's like that's not really how it works for me, I don't think. It's like I interact with tons of people in the world, and there are a lot of people who I'm like, damn, you are awesome in these ways. And I wish like sometimes that's like good enough for me to just be like, that person's awesome, that's not for me. But there's other times where it's like, I want to be like that. and then you work like I don't know. I think it's just good to like make sense to just look around and try to be the way you want to be and like be conscious about it. Have you had that happen to you in tech? Yeah, there's been plenty of people that I've worked with where I'm like, I like the way that that guy does this, handles this type of problem, right? But I wouldn't give you like specific names. I think it just makes like I think what I'm trying to get at is like I suspect that your question was like almost pointing towards like a name, right? Which is like I'm kind of fighting that concept in general and just being like you can take inspiration from a lot of people in a lot of contexts just everywhere. And I think that just makes sense like just try I think it's important to just try to consciously be what you want to be. Anyways, not that it matters. You shouldn't listen to my opinion at all. I'm just a guy who's coding on the internet. What the fuck are we doing? We're trying to use this frequency counter. Curious how you found yourself in this stuff? Oh yeah, it's just curiosity, dude. Now I get why you say don't be weird before every raid. Yeah, it's just like I wouldn't want to be weird. You know? It's important. All right. So I guess we configure this guy. Nothing in here is crazy. So can we read what his actual register definitions are? List of registers. So one of these is frequency, like I guess not just one of these. There's a lot of these guys. Frequency counters. So I guess we're probably gonna have to look at all these. So we have a clocks section already, right? So we're gonna be looking at like ref. It looks like are there multiple frequency counters? It says FC0 there, which makes me think that it could be more than one. But I don't see more than one. So we'll just call it, I guess naming them appropriately makes sense. But that means that we don't have to like duplicate these anywhere, right? We just have like FC0 delay. And this is gonna be like registers clock FC0 delay. Right? Plus 0x8C or something, right? This type of shit. Now, some of these guys, like, these all do have like reserved bits up top, huh? So the SDK code that we were sampling, they are just like slapping this shit in direct. But I'm not a fan of writing to these reserved fields. If we don't really know what they mean. Right? Because like theoretically they could put something in here that you shouldn't write later. I was joined. What are we doing? Is there a clock diagram for it? We turned on the USB phase locked loop to make a 48 megahertz clock out of a 12 megahertz clock. We think we configured it correctly, but now we're trying to figure out like, is that correct? And my initial thing was going to be, let's just hook it up to a GPIO and measure with the scope. But there is an internal frequency counter in the Raspberry Pi, the RP2040, and so we might as well try using that. So that's what we're doing. Is we're trying to figure out like, how do we fucking use frequency counter? I guess copy pasting their sample from the SDK thing, at least like the steps, probably makes sense. You can kind of like copy this for reference. I just don't want to lose it. Oh my god, copy. Jesus. We can call like function measure clock and paste this for now. So what fields are we trying to write here? It's status. We want status. We want, oh my god, dude, oh my god, fucking stop putting in things in for me, Jesus. We want ref kilohertz interval min kilohertz max kilohertz and source. Right, that's the stuff we need. Okay. Cool. So I guess we'll just do them in order. We can do them in order. Clock. Okay, so we can do like clock FC0 status. Boom. You don't need status, right? You know it's off. But we need it for the done at the end, at the very least. You know? And theoretically, between reboots, I think we might not know it's off anymore. You know what I mean? Okay, delete reserve fields, boom, 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 and then here we do some Vim macro magic. So we do like find the colon, delete word. Oopsies, that was a mistake. Find colon, delete word, paste, colon, comma, quote, lowercase. Pipe. Love it when a plan comes together. Boom, boom. All right. So that's status. What else do we need? We wanted ref kilohertz. So that's this guy who's bits 0 to 19. So this is a simple one. It's fields with, you know, maybe we call it freak at bits 0 to 19. Pipe. Then we said we need min and max, right? Interval min and max. Interval is bits 0 to 3. Okay, so it's... Can we just call this like val? We gotta be careful because some words that we would naturally use collide with other names in the structure that's generated. So we have to be a little careful, but I think val is okay. We'll see. So this is 0 to 3. When I try to make Vim macros, it usually takes me like 10 times longer than just editing by hand. Yeah, but sometimes that's the fun, you know? Min and max are both 24-bit. Min kilohertz. So this is frequency, and it's bits. It's actually 25-bit. Gotta be careful with that. It's inclusive. Maybe we just call this. We can actually do. We can just call this frequency. Actually. We'll call it maybe min max here, so that we don't have to define the type twice. It's the same thing. Okay. Then we go to main here and we start using that thing. So first, let's take build to make sure that see, remember val collides with the val field of the structure. God damn it. Okay, so value, maybe. There we go. He's okay with that one. Okay, so then we need to specify all of these guys in the clocks field here. So delay actually wasn't one of the ones we need. So ref kilohertz. Let's just copy the names. Min kilohertz, max kilohertz. Interval and status. Okay. So clock, FC0, ref kilohertz, which is offset 80 hex. Then this is min max kilohertz in it with base plus, you know, whatever the fuck. Min is 84. Max was 88. Interval in it with hex 90. And then status was 98. Okay. Hype. That one time when I was making it a Game Boy emulator, it felt super good to turn like 100 opcodes from the docs into the actual code with the macro. I felt like a god. Yeah, it feels pretty damn good when it works. It's pretty sick. Okay. So here, they say like while clocks dot fc0 status, read dot running or whatever. Does that compile? Do we get this right? Wow, that does compile. That's oh no, wait, maybe not, because we need to measure the clock. We need to call that function somewhere. Maybe we do that after UART in it. Then we can actually print. Isn't that kind of fun? So he's mad because clock fc0 status has a big T in it. Lowercase t, please, sir. Bool running was the right name, but this should be equals 1 because it's a U1. Part of me feels like I should change those U1s to bools, but fuck it. I don't, whatever. Then we set the reference clock. So he's using clock ref. So do we configure clock ref ever? Clock ref is used for watchdog and timers, so it's unlikely that we configure this. I might be dumb, but it looks like you can't use the frequency counter for a USB. We did not check that, huh? That's kind of funny. Did we just not check? No, it's right here. No, it seems good. Wait, no, that's clock generator. Fuck, wait, hold on. That would be funny if we did all this and we just didn't check. Clock USB is right here. I think it's good. I think it's good right here. Clock USB as a frequency counter source. I think we're chilling. I think we are chilling. Okay, so we need to... I don't think that we set clock ref ever, which means that we need to figure out what the default is there. You guys remember Coldplay? Like 15 years ago? They were kind of cool. They had a banger clocks, and I think it every time. You know? I just looked at the diagram where the frequency counter isn't connected to it. Yeah, I can see why, but I think that it's. Yeah, it does look like that when it says that. That was 20 plus years ago. No way. Clocks. What was it? X and Y. 2005. Oh fuck, that is 20 years ago. Jesus Christ. I think if I'd guessed year, I would have guessed like correct, but number of years ago, I guess wrong because in my mind, time stopped when COVID started. It's just like that. My brain never recovered. It's been like that forever. Okay, so what is like the clock ref default parameters? Please refrain from making us feel old. Sorry. My bad. Clock. One of these is like clock ref control, whose default is unset. So we probably want to set the reference clock up to read from the X oscillator, the like crystal itself. Which we haven't done. So let's do that. Yeah. Unless we've done it already. We have sys control. No, we have no ref control, so. Ref control. Alright, so this is boom. And for now, all we care about is setting the X oscillator. So we're gonna do in register definitions. We're gonna do clock ref control. We're gonna only say one field for now. And we're gonna give him a type here. Who is 2 bits, 0 to 1. And so now we define the type here of source. And we say, yo, this is 2 bits. And the fields are, the only thing we care about is xos, which is at 2. I think that that's chill. So now we should be able to initialize. Where do we initialize the x oscillator? Here. So can we do clocks ref control, and then we set like the source to x oscillator like this. Surprisingly, that compiles. Okay. So this just has to be done before measuring clocks, I guess. And then we have to wait for, do we need to like, it changes glitchlessly, so I guess it's fine. And then the divisor is 1. Okay, so I think we're chilling here, which means that now we know that the reference clock is 12 megahertz. So we can say clocks FC0 ref kilohertz is 12,000, right? 12 megahertz in kilohertz is times 1,000. I think that's fine. I don't remember what I called this frequency. I call it freak. Yeah, nice. Lucky guess. Clocks is a banger though. Yeah, absolute banger. Okay, so we set the clock frequency. We set the interval. So we're just gonna be like, what did we set this? What do we call that thing? It was value, and we'll just say LOL copied from SDK or from RP2040 data sheet, which says fix me, don't pick a random interval. But that's fine. We set the min and the max. This is gonna be mad because they were allowed to use. They're just like writing like max 32-bit integer, but we know that this type is supposed to be 25-bit. So I think we do this. Okay. Then they set the source true. Which did we not FC0 source here? We didn't do this one. So clock FC0 source. So this guy, you know, he has a field that is probably just a single field, bits 0 to 7, or 0 to, yeah, value. Source, we'll say 0 to 7. And can we actually give this guy like a little bit more of a complex thing? We'll give him like a little type. And this is going to be, I guess, source. And then we define an enum here for this thing, so that we can use them by name, baby. And this is bit size of 8, I guess. And fields, we will only define the one thing we care about. I mean, or we could just copy paste and do it all at once. Maybe that's fine. Maybe we can do this. Do one of our little Vim macros. So we say go forward word, delete word again, back, paste, colon, comma, delete, quote, replace with an actual quote, lowercase. Boom, 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 boom. Yeah, fuck it. We'll take it. Right. He doesn't like hex. Fuck. Which is fine. We'll just replace these. This is like 10, 11, 12, 13, right? D is, whoa. A, B, C, D. 10, 11, 12, 13. Yeah, should be right. E, F, 14, 15. Yeah, okay. And then here we're going to be like, word, delete the next 3 letters. Yeah, there we go. Cool. So then we need to define where this register lives. So somewhere we have to go fc0 source, which is at base plus 94. Yes. Okay, cool. And so now wherever the fuck we're doing this clock thing, we should be able to like set the source to source of clock USB. Was that the name that they used? Yeah, it was. Okay. Hype. And is that it? While we wait for it to be finished. So while we read clock's FC0 status, we read him and we look for done. While this is not equal to 1, we loop. And then we look at the result. So that means that we need FC0 result register here. Okay. One more, baby. I'm not gonna lie. I think this was harder than just using the scope. Like, if we just hooked this up to a GPIO and measured externally, I think that this would have been faster. But whatever. So we got fields frac at 0 to 4 and kilohertz at 5 to 29. True. Yeah, but I mean this isn't like wasted time. This is kind of like, this is nicer for sure. And if I didn't have a scope, you know, I'd be kind of, this would be hype. So here we go, like results is clocks FC0 results read, and I think we can just maybe debug this guy like this. Set a breakpoint and look at him. FC0 to result doesn't exist. True. Clock FC0 result initialized with base plus whatever the fuck offset is, 0x9c. Okay. And I guess we just hope to God that this works right. We hit a breakpoint. That's good. Result is 0. That's not good. Right? Surely the result should be, you know, a legal value. So what did we miss? Did we do all the same things they did? So they said, while it's running, we wait. Then they set the reference kilohertz to something. Oopsies, I just held a button that I didn't want to hold. Okay. They set the interval to 10. Min and max. I guess our max is slightly technically different, but the maximum of U25 should be fine, I think. We set the source to USB. I guess it's possible. Like, can we like measure the X oscillator? Oh, that's not allowed. What are our options here? Like, I would just love, oh yeah, X oscillator. Like, if we measure the X oscillator itself, that thing is definitely fucking running, right? So that is interesting. So measuring the X oscillator did in fact give us an answer. Whether that answer is correct feels kind of confusing. So can we just take a look at that? Because it didn't really look like what I would expect it to be. Info locals? Oh yeah, okay. So this did in fact give us kilohertz of 12 kilohertz exactly, or 12 megahertz exactly for the crystal. So that's good, which means that actually maybe the USB clock is not configured correctly. Right? If we read clock USB, info locals, he gets 0, which is a good indicator that it's wrong. Which is kind of sick. That's kind of why we did this, to prove that it works. So we can say it's not correct. Good stuff. First time message. I don't know about Zig, but somehow I can follow your approach. These datasheets have constantly shit tons of register definitions. It would be great if AI could extract them as code snippets to save so much time during dev. Luckily, there's Vim macros. Yeah, I could see that, but, but, um, this is the type of shit where I think reading someone else's copy of it is very likely to miss a mistake, right? I think that it would be very easy to like glaze over and miss something. And I think it's also very likely that these neural networks, you can't trust them, right? It could just like shit itself on a couple registers and you would just not notice. So I'm okay with doing it manually. Um, so yeah, not sure. And the diagram is wrong, it's connected to USB. Yeah, I guess we don't know. Do I need to turn on the USB? Oh, just connected to Watchdog? Oh, yeah, I see what you're saying. The frequency counter? You're saying that, like, this diagram is, like, frequency counter only connected to Watchdog. Confusing. But I'm pretty sure this is wrong. Pretty sure. I think what's more likely here is that we didn't turn on clock USB. Like, there's this clock USB control that I don't remember ever configuring. So this is probably it, right? We have the PLL set up, but maybe the clock that is being supposed to be driven by this thing is not hooked up at all. So starts and stops the clock generator cleanly here at 0 seems likely. It seems likely that we have to turn this on. And then everything else I think is just fine. I think. Also, it's not rare that there are bugs in hardware SDK. If you know the datasheet by heart, then you'll know to look up the details, and it's easier to rule out problems that you may. Yeah, I agree. And like AI would kill your like intuition there. Um, last month I spent like a week because the HAL I was using was bugged. Yeah, that's a classic. That's a classic. That's why like when I was looking at like the Raspberry Pi Pico SDK, I mean, part of this is a meme, right? Obviously, like what we're doing is the hard way and not necessarily reasonable, right? But also, I don't think that the Raspberry Pi SDK is reasonable either. There's a lot of like magic in that thing that would make it very hard to diagnose a problem if something was wrong. Like just the way that the thing is set up, there's a lot of like just make this function and like the interrupt handler will call it, and it's like what the fuck, you have to like dig through their like crt0 assembly to figure out like which functions are even valid to define, and they're probably documented somewhere, but I don't read docs, you know, like some fucking loser. And so like I do think that it's easy for there to be bugs introduced in that layer, and I just don't like the idea that I would get bit by that. And then you need to go through the details of the spec anyway, so it's kind of not feasible for robots. Yeah, makes sense. Um, Not sure if there's any good alternative to actually understanding stuff. I feel like taking shortcuts would bite you in the ass sooner or later if you don't know what's going on. Yeah, I think that like the art of programming in general is knowing when to take that shortcut, right? Because I think that you can always go deeper. And if you were starting out and you're like, I print letters to screen, there's a lot of stuff that happens between there. And if you were trying to understand like how a transistor works before writing Hello World, like you would never move forward. Right? So there is a line somewhere, right, where you're okay with trusting that the CPU will execute code, right? Or you're okay with trusting that the C compiler will generate valid assembly, right? And so I do find that there's an art to knowing when you're debugging something, like building an intuition on what stuff to ignore for now. You know? I mean, it's always hard, but like I could see a world where letting an AI scrape the datasheet and then digging into it later if you've given yourself a high level overview, maybe that's fine. Maybe it's kind of like a little bit more hands off than I would like to be, but I could see a world where that's okay. You could make that trade. The thing that worked for me was to feed the specs and manuals to ChatGPT and talk to the docs. That's an interesting approach. Yeah, I've never tried that, but I've heard good things. All right, let's try to fucking turn on this USB clock. So after, I guess we'll say init USB clock instead of init USB PLL. And then we can turn on the USB clock here. So once the PLL is initialized, we have to attach PLL to clock source and enable. So this guy is this clock USB control. Clock USB control. And this guy has a bunch of stuff. I think that we could just ignore everything except enable. Yeah, fuck it. That makes my life easier for now. Which means that we don't actually need that comment because nothing else is getting touched, so. Clock, USB control, init with base plus whatever the fuck this is, 54. We go clocks, USB control, modify, enable 1. Then everything else is fine, right? Out of reset. Phase stuff, nudge stuff, enable 0, kill, don't care. Aux source 0 is the USB by default. So I think it's fine. I think the linker is something that's glossed over really hard in beginner programming classes. Then when you actually need to understand, it's a huge cliff. Dude, yeah, I think that like, I've heard from friends, like, I guess like also interacting like with juniors, like even not with juniors, like you can make it. There's a lot of people who have made it very far into their career as like low-level C developers that don't understand like object files. And to me, it's crazy. I don't really understand how you could make it that far. Not because like you're stupid, fuck you, how do you not know? But more like I don't understand how you could choose to ignore that for long enough that it hasn't been a problem for you yet. It's like impressive to me that you haven't hit problems that made you understand like what's in a SO or like how the loader link, like how SOs are loaded, right? But it is common, and so it's funny if you me and a friend, I've heard, like I know from myself and from working with other people that you just become like the build guy if you know that stuff, which kind of sucks. Which also might kind of explain why people don't understand it, right? Because you end up having to do a bunch of shit that you don't want to do if you get it. My juniors just write stuff on top of the OS. No need to understand object files if you're not interested. Yeah, I think that makes sense. But like, I don't know. When you're like, why the fuck is this symbol not defined? It's like that's like a thing that you have to understand somehow. You have to like be able to debug that. Okay. Info locals. Result. Oh, kilohertz 9600. That's interesting. So that means that we are reading the USB clock. It's not 0 anymore, which is good. but it being 9600 is really fucked. Right? Am I crazy? What the fuck? So what happens if we change our PLL parameters on this? So say we like lower these or increase one of these dividers from 5 to 6. Do we see this value decrease? Yes. Okay. Weird. What are your reasons to use Zig for the firmware? I'm a C background and don't know much about Zig. Zig is like, I haven't really done much investigation on this topic in general, right? Let's be clear. The path was a lot of C++ dev into a lot of Rust dev, and then I tried Zig one day and was like, oh, I like this language, right? And so like the comparison, I think of it as Rust is to C++ as Zig is to C, right? There's a lot of like kind of niceties that Zig has over C without like treading itself into C++ Rust hell territory, right? It's like it just feels like a sane language. It's got optionals, it's got errors, right? So like those two things on their own are a huge improvement over C in my mind. But also like their behavior, their rules around like undefined behavior and all that, it just feels like a nice language to me. It feels like at no point am I like confused by what the language is. It doesn't like surprise me ever, which is good, right? But it's lower. It's kind of like more manual memory management-y than Rust. It lets me like, poke and prod things the way I want. It lets me experiment the way I want, where Rust would get in my way a lot. But both Rust and Zig have like this nice, what's it called? Attribute where they don't shock me, right? Where in C and C++, I'm often surprised, and I don't like being surprised by like the language. But that might just be like a me thing, Okay, so interestingly, we are measuring this clock, but it's not getting the right value. Now, if the reference clock on the frequency thing needs to be faster, then we might be running into problems. Also, we saw something about the frequency counter. If we've set 10 here, then our accuracy is 2 kilohertz. I don't know what that means. Let's just crank this value up to 15 and see if that changes anything. Because then the accuracy better. Info locals. Still seeing that same 9.6 megahertz, which seems wrong. Now, this could be we've got a problem to bisect here. Is the USB PLL wrong, or is the frequency counter wrong? Right? It's hard to know, but we do know that if we use the frequency counter to measure something else, like the X oscillator, what was it? Then we get the 12 megahertz that we want. So it seems likely to me that this guy is initialized correctly. However, what if there is a constraint on this guy where he can't measure something too fast? That's a possibility. So we should at least read a little bit about the frequency counter to make sure that we're not doing something that we can't do. Measures the frequency of internal and external clocks by counting the clock edges seen over a test interval. The interval is defined by counting cycles of clock ref, which must be driven from X oscillator or from stable external source of known frequency. User can pick between accuracy, blah, blah, blah. It doesn't say... Okay, using the frequency counter. Programmer must set the reference frequency. Set the mux position of the source they want to measure. Yep. Wait for done. Yep. Read the result. And we define a frequency. Okay. Can also be used in test mode. This allows the hardware to check if the frequency is within a minimum frequency and a maximum frequency set in these. In this mode, the pass bit will be set when done is set the frequency. Otherwise, either the fast or slow bit will be set. So that might be an interesting thing to look at. status dot clock FC0 status. So we have pass, fast, slow. Okay. So let's see. So he's saying, yep, we sure passed. We were within the range. Now, what happens if we clamp that range down? Right. So we go into here and we're like, make sure that you're below, 9,000. Right. He's gonna be like, I am too fast. Okay, so that's good. And if we then crank this up to 10,000, he'll say that he passed again, I assume. Daily Coder, thanks for the tier 1. Much appreciated. I don't like ads, I like your content. Thanks. Oh, thank you. Much appreciated. Yeah, okay. So this thing is responding in the way we would expect, right? Like the status register is correctly saying, like, if I set my min and max to the range of 0 to 10,000, we're within the range. And if we're set from 0 to 9,000, it's too fast. Problem. Hologus, thanks for the prime. Much appreciated. Which means that like the frequency counter, hand wavy, is reading 9.6 killer or 9.6 megahertz. Okay. This is fucking stupid. Why the fuck did I type this? This is just the answer, right? We're dividing the input clock by 5 for no fucking reason. Why did we do this? Were we trying to do something else and our brains just weren't on? This should be 1. Always should be 1. Yeah, 48 megahertz. Oh, another prime. Thanks, guys. Sprabs, thanks for the prime. Yeah, I don't know why the fuck I had written this. But just as a reminder, the way this guy is set up is we have, The Rock. Have you guys seen that photo of The Rock head in neck fold, face in neck folds? This thing is like one of the funniest things I've seen ever. This thing cracks me up so fucking much. The Rock, is this like a Google thing? The Rock, like this. Have you guys seen this shit? This shit cracks me up so fucking much. And then there's one where they flip them. This thing is like just it's the funniest thing I've seen in my fucking life. I don't know why this just gets me. It gets me so good. It's because the neck folds, they look like a face, Anyways, so we got The Rock. This is like the small man in the bodybuilder outfit where the neck muscles look like their actual shoulders. Oh yeah, those are so funny too. Yeah, those are good. So this thing goes into the PLL as the reference, but this thing like might be divided by something first, right? So we have like 12 megahertz. We set this to 5, so then our thing was probably what's 12 over 5? That would probably explain the problem. 2.4? That doesn't explain shit. So then this guy goes into like the PLL, which is your like little feedback loop with like your like ref. Oh, maybe we were trying to set this divider here. So there's supposed to be like, you have your oscillator here. Then you adjust the speed of this oscillator to try to match whatever came in here. And I think that was supposed to be 5. No, that's this one. That's the 100. This 5, we just copy pasted from these dividers at the end, right? So at the end, we have this guy running at like some like fast thing that's like locked to the 12 megahertz. And then we divide this output twice to get 48. And yeah, I guess we just accidentally wrote 5 there instead of 1. So that's fine. Everything else is set, so. think we're chilling. Info locals. Yeah. All right. So we got a 48 megahertz clock. Let's go, baby. And it turns out that it was a good decision to do this on its own instead of trying to do USB in one shot, because that took an hour and a half. And so we haven't even started on any of the USB stuff. So we would have definitely gone over time. But yeah, okay, cool. PLL configuration, honestly, shouldn't have been that hard. In fact, it wasn't that hard. In terms of like actual PLL configuration stuff, ignoring the fact that we got a parameter wrong, like this was like 30 minutes. And checking that it was right was like another hour. So I don't know. Sometimes it just goes that way. But pretty hype. Happy with that progress. I guess tomorrow should be another USB day. I guess there's a chance that it becomes a I bought a bunch of like input measuring stuff, so I might kind of pivot there, because the USB, all of this USB stuff, it doesn't really affect the construction of the controller at all, right? So my priority should really be focusing on getting the software components that we need to make sure that the wiring for other stuff is like the way we think it should be. When UART, so we can still debug print. Oh, we actually do have UART right now. I just forgot. Right, so we could do here running at this many kilohertz. We could do this right now, actually. If we say somewhere that we want to picocom. Hold on. We'll prove it. picocom here. Running at 48,000 kilohertz. I just forgot. Yeah, what was I saying? Yeah, so it's important for us to get the components I'm less sure about, which like I'm not super confident on the electrical behind the joystick. So if I have the chips for that tomorrow, we'll probably do that. But if not, then we'll probably do another USB day, or I might start doing interspersing hardware and software days, because I've been kind of working on like controller hardware for the past couple weeks, and I know that like people on YouTube just do not give a fuck about the hardware stuff. So I might alternate so that at least like the YouTube is still getting fed software content, but I'm still making progress on the hardware side. Not sure. We'll see. So those are the options for tomorrow. Thanks for watching. If you liked what we saw, we stream most days at 12:30 Pacific time. We try to aim to finish before 4 o'clock Pacific time. It is 3 now. So, you should see us online like 2.5 hours ago to an hour from now on a typical day. We haven't had very many typical days recently, but that is the way it goes sometimes. With a project with more unknowns, it's harder to predict time. So, that's the schedule. We're working on this Xbox controller now, but there's a lot of stuff in the backlog. So if you want, or sorry, backlog is like the other way. It's like the future. There's a lot of stuff in the front log. Also doesn't sound right. We've done a lot of stuff before. So if you want to check out the YouTube, there is a bunch of links. There's a bunch of like playlists for like operating system, like terminal emulator, Google Maps replacement, like image editor. There's all sorts of fun shit in there. We kind of just focus on whatever the fuck brainworm is in my brain at the time, or at right now. So check that out. We usually split the stream into 2 components, right? There's like happy hour and the main segment. You're seeing the main segment now, but there's stuff that is less nice for YouTube. Something that's harder to title, something that's harder to thumbnail, things that like might just get less engagement in general. So if you want to see that stuff, it's typically at the front end of the streams, if you catch us live, or we archive the happy hour segments to Patreon. They're on Twitch if you sub, and YouTube member. So if you want to consider supporting and to get the extra content, pay in the appropriate spot. This content will end someday when I run out of money, so every dollar I make does extend the lifetime by some amount. So if you want to support in some way, that is what you get, and that is how you do it. I think that's all the plugging and chugging I'm going to do. YouTube, peace out, and Twitch, let's find someone to raid. New name.